I spent about 15 years working on Wall Street, and one thing that always bothered me was how customers almost always lose out in this whole game. And this is a very famous story, very famous book. I think the book is like maybe 50 years old, and it's called Where Are the Customers' Yachts? And the story goes like, if you go to Wall Street, you can always find the yachts belonging to the brokers and the bankers, but never the customers. So there's more than just the boats. It's also about how every year, just in the United States, we pay about $600 billion in fees to fund managers, folks who run our accounts for retirement, 401k, all that stuff. And after paying them, we actually come out worse. So it's not just that we don't have yachts, we actually pay them to set fire to our hypothetical yachts, right? So we will try to use Python and a few hundred lines of very simple code to find our own yachts. Okay, disclaimer, blah, 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 investment advice is not. It's purely for fun. Use common sense, go find a broker. No, don't do that. All right, so I spent 15 years working on Wall Street. I'm a geek and a quant. I did some high-frequency trading, automated trading, and now I mostly do data analytics and some machine learning. I'm a long-time R user, so if my code is a little bit not Pythonic, please forgive it. Okay, so what will we do here? We'll first try to quantify the cost of underperformance. And then we will try to build a heuristic portfolio allocator. So what that means is, like, when you read on the news and say, hey, how should I invest the money in my 401k or even in my other accounts? People say, oh, it should be 40% stocks, it should be 60% stocks, 30% bonds. You should have real estate, you should have commodities, you should be investing in Asia, you should be investing in emerging markets. So you get all these like heuristics, all these rules. And then when you actually go to Vanguard and open up, say, show me all the index funds, you get like 150 index funds. And you're like, how do I do this? How do I actually go about picking these funds? And I have personally had this problem for a long time. My friends were like, hey, how do I do this? And just the choices overwhelm you. So we want to build a very simple, easy to understand heuristic portfolio allocator that we can actually play with and see what it does. And once we get it to give us the portfolios, we actually want to see how this would do over the last 5 years or 10 years or even 1 year, let's say. And so these three things, I could not find something that could do the last two basically anywhere. I did find one fun performance simulator that came out a few months ago, but if you go to the Vanguard site, or if you go to Fidelity site, or if you go to Morningstar, or if you go to Charles Schwab and say, hey, I want to pick up these 5 funds, and I want you to show me how I would have done over the last 5 years, 10 years, 15 years. They can't show you that. So it's really a very big barrier. Okay, so we'll try to do, no. Oh, I think the computer went to sleep. Sorry, my bad. So let's see. Hello. Give it a second. There's a bug in the OS X frame buffer. It does this after you go to sleep.
Like the latest one?
Yeah. Now, actually, I'll do that and do this again. Let's see. Okay. And all right, we here, and we cannot get the presentation. All right, let's do this. Okay.
It has again, we need to turn on the
All right, okay. Go back. Oh, the meter got turned off. Okay. I'll try to not let go to sleep. Thanks. Okay. All right. Let us do this again.
When I reload
There you go. I think that has just gone to sleep. Okay. Let's see if I can do it from here. Okay. Great, thank you. So the way we'll do that is we'll use something called the GNU Linear Programming Toolkit to set up the problem as a linear program. And PyMap programming allows us to express that language very easily. And then we'll use some pandas, NumPy, matplotlib to actually plot the data. And I've already scraped some data from Yahoo using pandas and by hand. And we will have some pie charts. So I'll put the whole thing. You can't follow it along because a lot of those, it's very hard to install the GLPK. You have to actually compile an older version to link it to Python. So it's not that straightforward. So I was trying to do it in a notebook, but I couldn't get it to actually load into. So I'll push the code to GitHub so you can look at it from there later on. Okay, so first we will look at the cost of underperformance. So we know that active managers lag index fund between 0.5% to 0.8% due to fees. We also know that even if you just go pick index funds, you have a lot of these things like target date mutual funds, which charge another 5, 10, 20 basis points. And then you have managed accounts. And then if you have a 401k in a company, the funds you have in a 401k are typically far more, they cost far more than if you went to a broker like Fidelity or Vanguard. The first thing we'll do is we'll try to quantify the cost of losing returns as low as 0.2% or 20 basis points over 30 years on $100,000. So now, let's see if I can, yes, this works. Okay. Sorry, I'm an old school Emacs user. Okay, let's see. Oh, my Windows. Okay. All right. We have a simple tool here. This is basically just using NumPy in the back end. And the NumPy calls, there's only like 2 NumPy calls in the whole thing. And most of the code is basically plotting. So what it's showing you is how much money you would lose. Let's say you were getting returns of 8% a year, right? And you're getting returns of 6% a year, and you were losing about 20 basis points, and it's not coming through on there. So on $100,000 over 30 years, in the present value, you would lose about $16,000. Simply if you lost 0.2% in returns. Now we can actually, let's say I said, hey, I'm actually going to make 7%. And I've set inflation at 2% in this model. You're losing almost $27,000, $28,000 in present value in your account with that lag. So this number here, slightly mislabeled, this number here is actually how much you're losing by going to an active fund or by picking very high cost funds. And this is showing you the loss in dollars over 30 years. And you can actually come in here and you can say, what if I put in $3,000 additional every year, what happens? Which is you're putting about $250 every month additional into your 401k. In that case, if I am underperforming by 20.23%, I'm losing $60,000 over 30 years in the present value, right? If I discount it back to today. So that is a very significant number. So clearly, we really want to pick up those last 10, 20, 30 basis points. And that is the takeaway from this. So really what we want to do is we want to put together a portfolio of funds that is cheapest cost while satisfying all my other constraints. So how are we going to do that? We're going to set up what's called a linear program. And we'll try to minimize the sum of over all my funds of the fees, which is the percent you pay to the manager, times the dollars. And then you're going to subject that to various constraints. For example, the funds require that you invest $3,000, or you invest $10,000, or invest $20,000 as a minimum in the fund. You might have your own constraints, like, hey, I want to only be 40% in the US, I want to be 30% in Asia, 20% in other emerging markets, so on and so forth. And then you might have asset constraints. So I want to have half in stocks, quarter in bonds, real estate, commodities, so on and so forth. So that's my goal. Okay. So here's some more actual categories: emerging, developed. So you might actually allocate to different to geographical categories, and you might allocate to the asset categories. And then you also have fund minimums. So those are your constraints, and you want your optimizer to find the lowest fee collection of funds that you can. Okay, so let's go back and do that. All right. Okay. So I'm just going to see it here, and then I'll walk you briefly through the code. Okay. All right, and then, okay. So first of all, I'll start out, and I will not give it any constraints. I'll just say there's no constraint on the fund minimums. There's no constraints on the actual categories, asset categories. There's no constraints on geographies. So I'm just saying, find me the cheapest fund you can, right? So it actually does the optimization, as you can see here. It ran the optimizer and it gave me a solution. And it said, hey, you can actually pick this fund. It's called the Vanguard Index Institutional Plus Shares, and it only costs you 0.02%, just 2 basis points. But this fund has a minimum of like $2 million. So we haven't actually added those constraints into our model. So we'll say, okay, that's great, but let's go back and add those constraints. Right? So now it goes and says, great, just put all your money in one fund, right? And this fund has a minimum of like $3,000, so it says go ahead and do that. And we say no, we'd actually want to have a more diversified portfolio, so we will now add constraints for assets and for geographies. Well, let's just first do, we'll do assets and geographies. Ooh, all right. That's what happens when you edit just before the presentation. Pardon me. I was doing something very cute. Okay, so now we said, we give it a bunch of constraints. We said, look, I really want to be in different geographies, and I also want to be in different asset categories. So now, given these constraints, go and find me a collection of funds that match my constraints, right? So we went and found this collection, And they said, okay, the average weighted fee for your portfolio is 10.5 basis points, or 0.1%. And it also was able to use Yahoo Finance to pull the data down and say, this is how it would actually perform over the last 1 year. So what I'm going to do is walk through the linear program, how we set it up, how we set up the constraints, and see how that was used in this one problem. So in general, linear programming is a very powerful technique. It's used a lot for routing packages. It's used for scheduling airlines. When you take a class in a school, they use it for scheduling all the classes to be able to maximize the number of students who can take classes. So I briefly want to walk through the actual setup of the linear program and see how that is done. Actually, and then let me open it up in Xcode because it will look slightly better. Okay. All right. So can people see this? Should I make it bigger? Okay. All right. So this is really the core of it. So if you remember, our goal was to minimize the sum of the fees charged by each fund times the number of dollars I allocate to it. So I want to minimize the number of the total dollars I pay as service fees or as the fund fees every year. So that is, actually, let me make it slightly bigger. That's fine. So right here, we're saying we want to minimize the fees. So this is basically an array of all the fees each fund charges. And that is, in the optimization, when it's done, that will be the number of dollars that have been allocated to the fund. So all I'm saying is I want to minimize this number for all the funds, and that's my objective. So that is the setting up of the initial linear program. And then we will go down and add a bunch of constraints. So the very first constraint is that each fund, let's actually open up Vanguard, right, and look at a fund. So this is a fund, right? And here, there's a minimum investment, right? And this is the asset class. Well, there are two of these labels, and this is all US based. So this is our data that's going into the actual optimization. The fees, and the amount, and the categories. And this also has other shares. So the same fund, but look, now this is cheaper by 0.12%. But you have to put $10,000 in it. Right? So in this constraint, what we're saying is, this constraint, what we're saying is, right here, is that the minimum investment has to be satisfied for the fund. So this array contains all the minimum investments of all the funds that we're feeding to the program. There's about 130 funds in there. And it's saying this is slightly, you have to break it up into two constraints because of how an LP works, but it's saying the fund amount has to be more than the minimum investment, basically. So that's the second constraint. The first constraint also was that I have a flag called variable called total dollars, which is how much I want to put in my portfolio. So in this case, it is set to, I think, $100,000. And it's saying, hey, make sure that you use all the money. Because the best minimum fee portfolio has size 0. So it will not allocate any money to any fund if you don't set that constraint. So that's saying make sure that you allocate all the dollars. And you have to give it a little bit of a wiggle room for other reasons. That's why I have the minus 100. So it's saying the total amount, sum of all the funds has to be between total dollars and less than 100. Okay. So that is the second constraint. And the third constraint is the geographical constraint. And what this is saying is I've set an array of weights. Go up here, right here. And what it's saying is in the developed, I want half my portfolio to be in the US. In Asia, I want 0. I want global 0. Emerging markets, I want 0.3%. And developed, I want 0.2%. Okay. So that is the geo constraint. And below that, I also have an asset constraint which says I want 20% bonds, 20% real estate, and 60% in stock. And you can, again, you can play with this. You can change it as you want. So this is the geo constraint right here. Right? And what it's saying is that for all the funds in one geographical area, if this fund is in the US, if it's bond, if it's stocks, real estate, make sure that the amounts added up are less than what I've said in the geo weights. And then the next one is the similar constraint of our asset class. It's saying, hey, this is a bond fund, no matter where it is in the world, make sure it is less than that. So we just do that, and then we fire it off. So this whole code is literally 150 lines. And you can accomplish with this what is not available on the web or from most brokers, where you come in and say, hey, here's my allocation. Why don't you go through and tell me what funds meet my allocation criteria? Okay? And then once it does that, it basically takes the data from Yahoo Finance and runs it forward and gives you a graph of performance. So, okay. So that is, and that's the actual performance. Now, let's see. What is missing? Okay. So we did that, low SV portfolio, and performance. So what's missing? If you're doing in real asset allocation, the way you pick your labels and categories, you look at the correlation matrix and find assets that are less correlated. I think in NumPy, there is SciPy, there's a correlation plot, so you can put it up very easily. We already have the returns in the program. You want to pick funds that actually have high returns. So you want to filter out the low returning funds. That's fairly easy to do. And what you really want to do is rebalancing. This is a very, very important thing. As the market goes up or down, your allocation, your various allocations will go in and out of your bounds. So at that point, you want to sell the ones that have grown and buy the ones that have underperformed. And that actually is a very significant source of alpha, so or rather of outperformance. So with this tool, it's very easy to rebalance. Every month or every quarter, you can rerun the tool and say, hey, give me my allocations. And then you can just call in. You can have it email you. And you can call in and say, hey, I want to sell $2,000 this fund and buy this much of that fund, and so on and so forth. So most fund companies charge for that service, right? And with something like this, you can do it for free. And then save that 10 basis points and maybe not buy a yacht, maybe you can rent one. Okay. And you would like to add ETFs, and that adds a little bit more complexity, and you would also like to add more richer labels for the assets. So if you go on Vanguard or Fidelity, they have like labels like large cap, small cap, growth stocks, income stocks, and then look at that from that point of view. Okay, so questions?
You said you'd throw out some of the code on GitHub later?
Yeah, I'll push the whole thing to GitHub.
Okay.
Yeah.
What's your GitHub?
It's Bansal R. Yeah, I should have put that up, sorry. Yeah.
So this is all done as
Correct, correct, correct.
Now, if you do go one step further and do take into account variance of the variance, it becomes a quadratic program.
Right. So,
Does that make it more complicated?
yes. I'm glad you asked that because it's a very good question. So I did that for a while in my whole career, right? When you do make it a quadratic program, so what it's saying is, why don't you look at the return and the risk and try to optimize for that? For that, you need a very clean covariance matrix. And there are people on Wall Street whose whole job is to clean a covariance matrix. And there is no well-accepted way of cleaning a covariance matrix. And there are other problems with it philosophically, like it changes a lot. Right? When there's a crisis, it all becomes one, and then it goes apart. So there are a lot of problems with that approach. And it might not even be actually something that you want to use. That's a whole other discussion. But if you look at asset allocation for retirement, most people have categories. So if you go to the online allocators, Wealthfront, all these guys, they will have a long article, like 6 pages long, and then in the end they will say we recommend 50-50, 30-30, 30-30, 20-20, right? So how you pick that number is up to you. What I'm saying is with basically very little code, right, and a simple database of funds, which took me about 2 hours to scrape, right? You can do that yourself. At least you can play with it and get a feel for it.
The other classic example would be shortfall analysis. I want to make 5%.
Correct.
Is there a methodology to implement?
So that involves a lot of assumptions about future returns and so on and so forth. I mean, you can use the lag simulator, which is showing you. Let's say when I retire, I want to have $200,000. I mean, that's literally two line call. It's like 8 lines of code. Mostly it's plotting, and there are 2 lines for calculating the future value, present value from NumPy. There's a call in NumPy for that. So you can play with that, and you can say, if I want to have this lifestyle when I retire, how much do I need to have? Right.
Can you do a comparison of this model versus the model which is I want to retire in 2045?
Yeah. So my goal of building this was really, I couldn't find anything like this online, right? Go and put those things in and actually use real funds, not like fake asset categories they have there. I want to use real funds, right? So you can actually use real funds and at least look at the past performance, right? And it's pretty easy to add portfolio statistics, like you want to have Sharpe ratio and beta and so on and so forth. You can easily add that to this because the data is already all there.
Yes. So I guess from the other side, what would you have to do to optimize the allocation? So what would be the best mix of you throw in 20 different allocations, and I don't care how they're allocated.
See, that's a very big question, right? And the reason there's a financial industry that makes $500 billion in fees while actually destroying returns is they all have different answers to that question. And that kind of shows you there is no real answer to that question because nobody knows the future. And also finance as a field, and it's getting philosophical away from PyData, but finance as a field is not only a science, right? So I'll give you a classic example. Bonds should not outperform stocks because bonds are less risky. But in the 2000s, for a 10-year period, bonds actually outperform stocks, right? It's kind of like saying, there's a gravitational field, there's a big hole in the middle here, right? Where you can kind of float up and float down. So that's kind of what finance is. And the reason you have these people who can destroy value and charge $500 billion, which I think is more than the income of Verizon and Comcast put together, right? Is there is no answer to it, and they peddle answers to it, which are non-answers.
I think that study actually only refers to actively managed mutual funds.
Correct.
And there's actually another study that if you take
Correct.
prediction picks of actively managed mutual funds, so in a sense like the top 25% of holdings, then the performance actually greatly increases. And part of the problem with the mutual fund structure is people are jamming 80 stocks into it, instead of picking like their 10 best ideas, they're picking their
Sure, but they also, I mean, for the fund manager, and I was a fund manager, so the fund manager, my personal optimal function is to have as many assets as I can. So they're not optimizing for you, I'm optimizing for me as a fund manager. So that doesn't work. I mean, clearly if you could do that, yes.
In defense of the industry,
Yes.
you're paying for diversification. You're paying dearly for diversification.
Well, how am I paying for diversification if,
Your example right there, if you want to own 10 stocks, right, you can allocate to 10. But if you're forced because of your investment committee, you have to own 80, now you have to pay for that diversification.
well, but I'm not criticizing the individual, I'm criticizing the industry, right? So, yeah. Sure. Sure, but today you can see, I mean, there is enough data on this. There's a State Street report that came out, and also. But what the point I'm making here is, even with all these options, people go to manage accounts, pay 1%, go to other funds, pay another layers and layers of fees. And today, with open finance and tools like Python, you can actually build something that can allow you to get a handle on it. Which, I mean, to do this 5 years ago would have been very, very hard. Very, very hard. So, yes, I'll push the whole thing to GitHub in a couple of days. Let's got to clean it up a little bit. Yeah. Great. Thank you.